All right, so we are looking at lesson 7-6 today, which is solving equations with rational numbers. We're going to be adding, subtracting, multiplying, and dividing, all four operations today, okay? The reciprocals for the IXL, this is what you're going to be using when you are doing the dividing, okay? All right, so example 1 is solve addition equations with rational numbers. Now the process is the same, okay? You're going to cover up what you're solving for. We're solving for x. That means we want to get rid of the positive 4.5, right? This is an addition equation. The inverse of addition is subtraction. So we're going to subtract 4.5 on both sides. Keep in mind, here is the balance point for our seesaw. And of course, this is 4.5, this is a number and its opposite, and that is equal to 0. So x plus 0 is equal to x, and then on the other side, we do the subtraction. So I'm going to have to do some borrowing here. Borrow from the 7, that gives me 6, and then 13 minus 5 is 8. And 6 minus 4 is 2. Don't forget to bring down your decimal. Is everybody clear? Now, here we have fractions. Those are also rational numbers, right? Now, when we are adding and subtracting fractions, we need to have what? No, we need common denominators, right? Now, these, you'll notice, the denominators are already the same. Is everybody with me? So we don't need to get common denominators, so we can just do the same thing. So we're going to cover up what we're solving for. Cover up the x. We want to get rid of this positive 2 2/5. So because this is an addition, we're going to subtract 2 2/5. So minus 2 2/5 on both sides. Okay, so here's the center point of our equation. This 2 2/5 and a negative 2 2/5, that's a number plus its opposite, that's equal to 0. X plus 0 is x. And then on the other side, now we can subtract. 4/5 minus 2/5 is 4/5 minus 2/5 is, what's 4 minus 2? So 4/5 minus 2/5 is 2/5, right? 2/5. And then 6 minus 2 is 4. So we end up, x is equal to 4 2/5. Example 2 is solve subtraction equations with rational numbers. So the process for solving a subtraction equation is, again, it's still the same. We're going to do the inverse of subtraction, which is addition. So in order to solve a subtraction equation, we add. So we're going to cover up the x. This shows me that I want to get rid of the negative 7.5. And in order for us to do that, we're going to add 7.5 on both sides. Now remember, when you're adding, you guys, you need to make sure that you line up your decimals, okay? So here we have a negative 7.5 and a positive 7.5. That's a number plus its opposite. That's equal to 0. And x minus 0 is x. And then on the other side, now we just add. So this is going to be 5. 2 plus 5 is 7. And 6 plus 7 is, 13. All right. So now here we have 4 is equal to x minus 1/4. In order to get that x by itself, what I need to get rid of? The 1/4. So because that says minus 1/4, we're going to Add 1/4. Very good. So we're going to add 1/4 on both sides. So here's the balance, there's the equal sign. This is a number plus its opposite, negative 1/4 plus 1/4. That's equal to 0. What's x minus 0? X. And then on the other side, do I need to get common denominators for this? No, because it's just a whole number adding a fraction, right? So this is 4 plus 1/4, which is 4 and 1/4. All right, so example 3 is solve division equations with inverse operations. Now, when we have just these decimals here, it looks kind of weird, but the process is still the same, right? We want to get the x by itself, so we're going to cover up the x. What do I want to get rid of over there? 6.2. Very good. So that 6.2 is what we're going to divide by, because this is a multiplication equation, right? Actually, my heading is wrong. This is solve multiplication equations. Let me change it. So here, because this is a multiplication equation, make sure I change that heading, we're going to divide by 6.2. We're going to use division to solve the multiplication. So again, over here, 6.2 divided by 6.2, that's equal to 1. And 1 times x is equal to x. And then over here, we can use our calculator. We have 49.6 divided by 6.2, and that's equal to 8. Very good. So x is equal to 8. So now, this next example B, I want you to just write down the problem for now, okay? But the work that I'm going to show you right now, I don't want you to write it down. I just want you to pay attention to what I'm doing, okay? So, here, that's a multiplication equation, right? And the multiplication, if I do my inverse, is division, right? So what are we going to divide by to get that red dot by itself? 1/4. So we're going to divide by 1/4 on both sides. Again, you don't need to write this down. Just watch. So we're dividing by 1/4, right? So what's 1/4 divided by 1/4? That's 1. Any number divided by itself is 1, right? So that over here is 1 times x, which is equal to x. Now, here, this side says 7/32 divided by 1/4. Does everybody see that? How do you divide fractions? Keep, change, flip. Very good. We're going to multiply by the reciprocal. So keep, change, flip. Now, watch what happens. We have 7/32 times 4/1 is equal to x. Does everybody see that? See that 4/1? That's the reciprocal for 1/4, which is right in front of the variable. Does everybody see that? So when we are solving a multiplication equation that has a fraction as the coefficient, you just have to multiply by the reciprocal. Is everybody clear with that? So, I'll finish this problem real quick. We can simplify before we multiply. And we end up, x is equal to 7/8. Okay? Now, this is what I want you to write down. Multiply by the reciprocal. And now I'm going to show you how to show your work on that kind of problem. All right. So we want to get rid of that 1/4. If I multiply this 1/4 by its reciprocal, right, the reciprocal is 4/1. So we'll multiply times 4/1 on this side. So we're multiplying by the reciprocal of what is in front of the variable. So if I multiply times 1/4 on this side, what do I have to do on the other side? I'm sorry, if I multiply times 4/1 on this side, what do I have to do on the other side? Right, multiply times 4/1. Now, so what is this equal to? That's 4/4. What's 4/4 equal to? 1. Does everybody see when you multiply by the reciprocal there? So what's 1 times x? X. And now, on the other side, can I simplify before I multiply up there? Yeah. So 4 divided by 4 is 1, and 32 divided by 4 is 8. And now, when we multiply straight across, we get 7/8. You get the same thing. Example 4 is solve division equations with inverse operations. Now, what do you notice about these problems? What do they have in it? Well, yeah, we do. We've got mixed numbers, right? Can I get a reciprocal? Well, we don't need a reciprocal here, but can I do this multiplication without changing that mixed number? No. So for the mixed numbers, we want to make sure we change the mixed numbers to improper fractions. Okay? Write that down. So we're going to change the mixed numbers to improper fractions. So 3 1/2. You guys remember how to do it? In this direction, what are you going to do? Yep. And in this direction, we're going to, no, not divide, add. So 3 times 2 is 6 plus 1 is 7. So this is going to be 7/2 is equal to x over 6. So now we use our cover-up method. So we'll cover up what we're solving for. What do I need to get rid of to get the dot by itself? 6. Now, this says x divided by 6. So what am I going to do with that 6? You're going to multiply by 6. Is that clear? And if you want to put it over 1, you can. I'm just going to leave it like this on this side. Because what happens to those? What's 6 over 6? 1. So this is equal to 1. So what's 1 times x? X. Can I simplify over here before I multiply? Yeah. So 2 divided by 2 is 1. And 6 divided by 2 is 3. And so 3 times 7 is 21 over 1. Do I have to put it over 1? No. So we're just going to write 21. Is everybody clear? All right. For this example, what's the first thing we need to do? Very good. What's my improper fraction going to be? Nine plus 1 is 10. So this is going to be, very good, 10 over 3 equals, and then x over 6. So now if I cover up, what do I need to get rid of? The 6. Again, it's a 6. Okay, so we're going to multiply times 6 on both sides. Times 6. I'm going to put the 6 over 1 on that side. So those 6's cancel to 1, right? And 1 times x is x. And then over here, can I simplify on that side? Yes. So 3 divided by 3 is 1, and 6 divided by 3 is 2. And when I multiply straight across, what do we get? 20 over 1, which is just, all right. Is everybody clear?